Welcome to another screencast from Professor Stick's Guide to the Universe. I had a student ask me the other day when we were discussing back EMF in motors whether that means that a motor can be a generator. So I thought, rather than answer the question, let's have a look. I've got here a simple brushed DC motor hooked up to a 5-volt power supply. I've got an identical brushed DC motor. This one's hooked up to a load in the form of two LEDs, both wired in opposite directions, and we've got one multimeter which is measuring the voltage across that load and another multimeter which is measuring the current through the load. So if we start the first motor and use that to drive the second motor, we can see that we generate a potential of around about 2.5 volts. And once we get up to speed, a current going through the load of somewhere around about 2 milliamps. So our voltage going in to the first motor is 5 volts and the current going in is about 0.2 amps. So the power going into the first motor is about 1 watt. The voltage coming out of the second motor is 2.5 volts. The current coming out is 2 milliamps. So the power coming out is about 5 by 10 to the minus 3 watts. Let's see what happens if we drive the second motor backwards. Once again, we're able to generate a current and a potential difference, but this time the current and the potential difference are negative, and you can see that it's going through the red LED rather than the blue LED. So we've got a voltage of around about 2 volts and a current somewhere around about, it's pretty variable, but somewhere around about 25 milliamps. So our out voltage is 2 volts and our current is about 25 milliamps. So this time we've got a power out of around about 50 by 10 to the minus 3 watts or 5 by 10 to the minus 2 watts. Not the most efficient way to generate power, but it certainly demonstrates the principle. So that's it from Professor Stick's Guide to the Universe. And remember, don't panic.